welcome back to the final video for our last section here in this module for section 9.5. So this one has to do with climate change, and we're going to look at how exactly what we've been talking about with the greenhouse effect and greenhouse gases increasing, how that is kind of fueling climate change. So we need to remember that climate applies to the weather conditions over a long period of time. And that's going to mean over 30 years. Okay, so we're talking about temperature, we're talking about precipitation. Okay, so a little bit of a funny meme here for you. Moving on. So it is important to consider the fact that Earth's climate changes naturally. So we have talked about that before. There are major shifts in temperature from time to time. Now this is over long periods of time. And there are some periods where it could be warmer. There are some periods where it could be cooler. And we are currently in a period where the climate is definitely warming, and that is backed up with data. So ice cores can be used. So we're talking about like in places where the ice is very thick, but ice cores from 800,000 years ago, we can look at the chemical composition of that ice, in particular the carbon dioxide composition of the ice, to look at what the concentrations of carbon dioxide in the air at that time was. Okay, so in this graph, we are looking at the carbon dioxide concentration in the air, in the atmosphere, over time for the past 400 years up till present. And then this is the temperature change in, again, the last 400,000 years. So the baseline here is 0, and you can see how it dips below and then comes up. So we have these cycles that happen, you know, about every 100,000 years. And we are currently in the middle of another warming cycle. So some of the effects of climate change include not just rising temperatures, we also have to think about what that might do. So that can mean that permafrost in tundras that is normally always frozen starts to melt, and that's a problem because methane can get released. Sea ice is melting at a faster pace, meaning that organisms that depend on sea ice are going to be in trouble. And rising sea levels also, that is harmful to coastal ecosystems, as well as a lot of human communities that have been developed on coastlines. That might mean that people, not just ecosystems, can get destroyed and they could get displaced. So now, let's take a look at each of those in a little bit more detail. So now with sea level rising, what might that do? Well, it could create new habitats, such as additionally flooded areas. So more areas where the continental shelf, so it's not very deep, but maybe new ecosystems will develop. But the other problem with that, again, human communities, we like water. It helps with things like transportation and other resources. There are a lot of coastal communities that can be negatively affected and may be displaced by the rising sea levels. Okay, and not only that, but as the sea level rises, the sun might not penetrate as far down to some ecosystems that are located on the continental shelf. Wind patterns can get affected. So we know that wind transports heat. A lot of that gets delivered directly to the equator where we have the most direct sunlight. The winds help to transport heat away from the equator, but that can get disruptive As the atmosphere continues to warm, it can impact the Hadley cells. So we're not exactly sure the exact extent of the effect, but we know that it could impact the Hadley cells and further affect the jet stream. Okay, ocean currents can also be affected because just like wind, they help to carry heat from places like the equator and the tropics to northern or southern latitudes. So the ocean currents could get altered, and that could actually drastically change some terrestrial ecosystems as well, because if the water, as it's moving, especially, you know, for example, take the Gulf Stream and then the Norwegian current, if suddenly this warm current is no longer going this way, these places up here in the northern latitudes, they might have issues where they're not getting nearly as much heat anymore. So their climate could really cool down. Soil can be impacted too, because with changes in temperature and potential more rainfall or less rainfall, more rainfall could mean more erosion. Less rainfall could also mean erosion through the wind. So neither one is really a good thing, right? It would institute changes on the soil. Some polar regions might have big issues, especially as ice starts to melt. So polar regions are probably going to be more negatively impacted as a result of what we'll say is a positive feedback loop, because normally ice, which is light colored, will reflect a lot of that sunlight. But as the ice is melting, as a result of warmer atmospheric conditions, less of that sunlight will get reflected and more of it will get absorbed. And the problem with that is that will lead to more ice melting, which will lead to more heat absorption, which will lead to more ice melting, and so on. So that's a positive feedback loop. As something happens and continues to happen with added effect, that is a positive feedback loop, right? So that is not a good thing when we're talking about ecosystems. Okay, so polar regions, the ice caps, you know, they're melting, glaciers are melting, and you can see the trend even just within the last 40 or so years that the volume of sea ice and the area that the sea ice occupies is becoming less and less each year. All right, so concept known as albedo. The albedo is the amount of light that gets reflected from a surface. So something that has high albedo, like ice or snow, will reflect a lot of the energy, like the UV radiation. So that's good to help to moderate the climate, reflect a lot of that heat back in the atmosphere and get that away from Earth's surface. So that will prevent excess heating. But again, the problem is that as the atmosphere is warming, the ice and snow are melting at a faster pace. They're not reflecting as much heat, so things get hotter, melts more ice and snow, and so on and so on. Okay, again, that's a positive feedback loop, because as this thing is happening, its impact is getting larger and larger, and it's not correcting itself. Permafrost, again, this is the soil in the tundra that is frozen throughout the year. It contains lots of methane, but as it warms, the methane is going to get released. And we know that methane is a major greenhouse gas. So this is another positive feedback loop. As the permafrost melts, methane gets released, which increases the greenhouse effect, which warms up the area, which leads to more permafrost melting, more methane being released, more greenhouse effect, more permafrost melting, and so on and so on and so on. Okay, so this is another example of a positive feedback loop. So the biggest problem with the loss of ice, and this is going to be the last issue that we talk about, is that animals like polar bears, they depend on the ice, not just for habitat, but as a food source, because animals like seals, they need to come up for air, and polar bears are able to get at them because the seals are only going to go to certain places to come up for air. But as the ice melts, they're going to have less places to be able to go to find the seals. All right, so this is the end of 9.5 and the end of our module. So answer all the questions and submit the Google form when you're done. Have a great rest of your break.